Okay, so now we're going to start the math section. This is just an introduction to it and some general tips that you can use in the math section. And then we'll start going into specific topics that you'll need for the math section. So the math section, that has two sections, or two subsections, I guess. The math no calculator section. That one's 20 questions in 25 minutes. So that's around a minute and 15 seconds per question. I think it's this one, you definitely can do every question without a calculator. It's simple. You don't have to do like 35 times like 50 or something, or 35 times 111, nothing like that. It's very simple arithmetic, but some questions take a lot to do by hand, so you might have to skip some questions, but that's okay. Don't let the fact that it says no calculator and that it's a little bit of time frighten you. Then we have the math calculator section. That one is 38 questions and 55 minutes. That's around a minute and 26 seconds per question. This one does give you more time, but it is more questions. Each of them also has 5 student-made responses at the end, or the one where it's like the little boxes like this that you fill in yourself. It's not multiple choice. The ones like that where you have to put the answer in it. So those, each of them has 5 of those. The first one has 5 at the end. The math calculator section has 8 of those at the end. So here are some strategies for the math section to hopefully make it easier for you. The first half of each test has the easiest questions, so do them as fast as you can. Don't spend a lot of time thinking about those. Don't be like, oh my god, this was so hard, and start psyching yourself out, because those are the easiest ones, I promise. Once you practice more, once you become really confident with the topics that you need for the SAT math section, once you do more practice tests, then you'll be more confident. So once you get to the actual test, remember, those are the easiest questions. Do them as fast as you can. Just write really fast. So once you get to the harder ones, you have more time to do those and think about them. And now, after I did a bunch of practice tests and I started seeing like a pattern that I started seeing that there's only really 3 things you can do for any question. Any question that you get in the math section, there are only 3 things you can do. You can either make or interpret an equation or proportion. A proportion is an equation, but whatever. So you can either do that, or you can do exactly what they tell you to do. And once we do more practices, you'll see examples of what I mean when I say do exactly what they tell you to do. A lot of times that just means you write down exactly what the question says, and they give you the equation you have to solve just by following the words they tell you. Or you can interpret a graph or a table. Sometimes they'll give you a graph and they'll ask you something about it. So those are the 3 things you can do. So when you feel stuck, when you feel like I don't know what to do, you just take a deep breath, close your eyes, take a deep breath, and think. There's only 3 things I can do. So what do I have to do here? Do I have to make or interpret an equation or a proportion? Do I have to do exactly what they tell me? Or do I have to interpret a graph or table? Sometimes you can do more than one. You can do maybe these 2, or sometimes it's all 3 that you have to do. But there's nothing else that you can do. So if you're stuck, breathe and think about these 3 things. Which one can you do? Next, you can plug in or substitute what looks unusual or weird for something more familiar. A lot of the times they give us problems that you've never seen before in class, in your high school. So they just don't seem familiar. So you think you don't know how to do them, but oftentimes you do know how to do them. It's just they look different. They made them more complicated, but you do exactly the same thing if they were more simpler. So here's an example. You have this, and you might be like, what do you do? I mean, it's just 2 fractions, they equal each other. What do I do? I mean, how do I make this equation? I can't do this. I don't know. So think about it, just change it. So what is this? This is really just a number, right? Because let's say x was, 1. Let's say x equals 1. Then this would become 1 minus 11. It would become 3 minus 11, and that would become minus 9, I believe. Yeah, minus 9, I think minus 9, whatever. Right? So then it's just a number. That just became a number. Right? It's really expressions like that, they're just numbers. A lot of the times people look at this and they get so intimidated by it because there's so many numbers, there's so many variables. It's like such a long expression, but in reality it's just a number. So since it's just a number, what would you do if it was just a single number? What would you do if it looked like this? If you just had a single number on each of the parts of the fractions, what would you do? In this case, you might be more likely to know what to do. What you do is you just cross multiply, right? You would just do 3x equals 20. X times 3 times 5 times 4. That's what you would do. And then since this is more simple, this might look like something you might be used to, try to put it like that. So since we did that there, we do exactly the same thing up here. We just cross multiply. So don't forget that, first of all, don't forget these expressions are really just a single number. And don't forget that just because something looks big and complicated, it doesn't mean you don't know how to do it. Try to put it in terms that might be more familiar to you. Here's another example. What would you do? Well, what do you do here? A lot of times people get this one wrong because exponents sometimes are hard, but just replace it. What would you do? What might throw you off is the fact that there's an n here and an f here instead of a number. You might be more used to having a number. So what would you do if there was a number there? If you're used to having a number, put a number there, think about what you would do. So what would you do here? You might say that equals m to the power of 5. Easy. How did you get that? Well, you did. How did you get that? You did 2 plus 3, right? You got m over 5 because it equals 3. And in reality, I'm so sorry. Okay, this is another example. What would you do if you had this? Well, what might throw you off on this one is the fact that the exponents are variables. Well, you're probably more used to the exponents being numbers. So just think about it. What would you do if the exponents were put numbers in it. It doesn't matter since you're just trying to think theoretically about it. So just put any number, let's say maybe 2 and 3. What would that be? Well, you might say right away that that's just m to the power of 5. Well, how did you get that? You got m to the power of 5 because you added 2 and 3. So since that's what you did if there was numbers, do exactly the same thing with the variables because the variables are just numbers, right? So you just do m and plus f. That's the answer. So don't think that you don't know how to do it. If it looks familiar but you've never seen it that way, try to put it in the terms that you're familiar with to see what you would do if that was the case. Another strategy is you can, when you can, plug in numbers for variables to make it easier to visualize. The previous example is kind of an example of that as well. Those numbers that you plug in could be numbers that you make up, or it could be answer choices. So in this case, you have if t plus 5 over t minus 5 equals 10, what is the value of t? Personally, what I would do for this one, I would just solve it. I would multiply t over t minus 5 to 10, and then I would solve the equation, right? But some people, to me, that's the faster thing. Some people, you could use your calculator and you can just plug this in for t. You could plug this in for t, you could plug this in for t, and you could plug this in for t and see which of those gives you 10. And if you're a little slower at doing equations by hand, that might be the best option for you. Just because that's not the best option for me doesn't mean it's not the best option for you. If doing that is faster, you can totally go ahead and do that. Instead of making up a number, obviously use the answer choices and plug them in to see which one gives you 10. This one, another example, let x and y be numbers such that negative y is less than x is less than y. Which of the following must be true? So it's really, really hard to visualize that. To me, it's just letters. Like, what? I have no idea. How do I know which of these makes sense? It's just letters. So why don't we just plug in a number so it's easier for us to visualize. We just have to plug in a number that fulfills that. So I don't know, maybe 3. 3 is less than -4, but 3 is greater than -4, but it's less than 4. And that's fine. And then we can try to put that in. So we said that x equals 3, and we said that y equals 4. So let's see which one is true. Let's see that one. That one we have the absolute value of 3 is less than 4. That is in fact correct. This one, it says 4 is greater than 0, and that is in fact, 3. 3 is greater than 0, and that is in fact correct. And then here, 4 is greater than 0, and that is in fact correct. So then D is the answer. If we had just left it as letters, that would have been a lot harder to visualize. So we can just plug in a number. The number doesn't really matter. As long as we made sure that this was still true, it doesn't matter what numbers you use. Okay, the next strategy is remind yourself that they have to give you everything you need. Do not doubt yourself. They have to give you everything you need. There's no reason that they would give you a problem that is unsolvable, right? You might not have the knowledge to solve it, but it doesn't mean that they don't have all the information you need. A lot of the times when I was in a problem and I didn't know what to do, I was like, I would go one way. I would maybe find the area of this square, and then they would give me something, and I'm like, I need this to solve the area of the square. I don't have this. What am I gonna do? Like, there's no way I can solve this. But there has to be a way. Maybe it's not the way I'm thinking about it, but there has to be a way to solve it. They would not give you a problem that you cannot solve. That also means that for the multiple choice questions, where one of the answer choices is there's not enough information to solve this question, that is never, ever going to be the answer. I have never, ever seen any of the tests ever having that as an answer. So don't ever choose that. You might feel like there's not enough information, but there has to be. There has to be enough information. So when you're doubting yourself and you're like, there's no way I can solve this, or I don't have enough, I need this, I don't have it, close your eyes, take a deep breath, and tell yourself they have to give me everything. They have to. So maybe the way I'm thinking is just not the way to go. What other way can I go? Because they have to give you everything. That leads me into ask yourself active questions. That means you don't stare at a question and think, what do I do? Because nobody's going to answer you. Nobody's going to answer you, what are you going to do? So you need to ask yourself active questions, such as, okay, they gave me the area of the square. What does that mean? How can I use the area? Or if they only give you one side length, maybe be like, well, okay, so I only have one side length. What does this side length mean? What type of square, what type of triangle is this? What does it mean if this is that? How can I use this number? Those are active questions. Actively use the material they give you to try to come up with the way to solve it if you don't already know how to solve it. Because if you just ask yourself, what am I going to do? What am I going to do? I don't know what to do. Then no one's going to answer you. You have to ask yourself active questions. You have to interact with the question. Otherwise, you're not going to be able to answer it. Use a calculator when it would save you time. There's some times when, for me, doing the equation by hand was going to be a lot faster for me than using the calculator. If you're a slower person at doing the equation, then maybe using the calculator is a better idea for you. It's really personalized, but only use it when it would save you time. I know we get nervous, we get scared that 2 times 2 is not 4, so we have to do it on the calculator. And when it comes to the time of the test, you have to trust yourself. If you're really having trouble, like if you're like, oh, what's 2 times 8? What's 2 times 8? I don't remember. If you really can't think about it, do it. But if you're like, 2 times 2 is 4, okay, let me just make sure it's 4, because I've done that too. Don't do that. You need to use it only when it saves you time. If you're stuck, you have no idea what the number is, do it on the calculator or anything like that. Only do it if it would save you time. If using the calculator makes you take longer, then don't use it. Do it by hand. The next strategy is answer the questions before looking at the answers. So that means more like I've given you guys this tip a lot for reading and writing. This is less applied to math because you just get a single answer. But what I mean is try to solve the problem. So they give you an equation or something. They give you something like that. Instead of looking at the answer choices, just solve it. Just solve it really quick. Just solve it, get an answer. And then let's say you get 5, and you see that 5 is one of the answer choices, choose it, continue. Don't look back. Don't keep going. Don't stop to be like, okay, what was A? Let me make sure that's not right. Let me make sure B isn't right. Let me make sure D isn't right. Let's not do that. Just if you got the answer, you got the answer. Choose it. Move on. Do not try to look at the answer choices at all. Usually, sometimes using the answer choices to answer the question is helpful. But for the most part, try to just answer the question without looking at the answer choices. Just use the question, answer it, get an answer, see if your answer is in the answer choices. Okay, and then finally, I think, just because your answer isn't there, it doesn't always mean you're wrong. So you might get an answer, you might get maybe like 6x over 12. That's not right. I mean, what if that doesn't show up on the answer choices? Does that mean you did it wrong? Not necessarily. Sometimes it just means you need to simplify more, or you simplify too much. So you have to just check, be like, can I simplify this, or is it too simplified? Is it just in a different term, with different terms, in a different form? Try to see if your answer, if you got 7 and the answer was 12. If you got 7 and 7 is nowhere to be seen, then that might be wrong. If you got 7 and all of the answer choices are equations, then obviously you did something wrong. In that case, there's no need to check, right? So just think about it like that. Sometimes it's just too simplified, sometimes you need to simplify more. Here's an example. Oh no, there's no example, just kidding. Okay, next strategy is if you can't draw it. If what they're telling you in the question is drawable, draw it, because most of us do not have the gift to visualize math in our heads. I do not have that gift. Most people I have seen do not have that gift to be able to visualize math in their heads. I have to draw it out to see it. So look at this question. Line L in the XY plane contains a point from each of the quadrants 2, 3, and 4, but no points from quadrant 1. Which of the following must be true? So if you just see that and you don't do a graph, you have no idea what it might be. You're like, okay, well, where's quadrant 2? Where's quadrant 3 again? I don't know. I don't know what the line looks. It's a line. Honestly, when I first did this, I didn't draw it, I didn't even realize it was a line. Like, this part was all the way in the beginning of the word of the problem. I forgot it was a line. It didn't look like a line in my mind. So the best way to solve this is to draw it. You have quadrant 1, quadrant 2, quadrant 3, quadrant 4. It tells you there's a point in 2, 3, and 4. You can literally draw it anywhere. I can draw this point here, a point here, and a point right here. It doesn't matter as long as there's a point in quadrant 4, 3, and 2. There's no point in quadrant 1. You just connect the dots. What does that line mean? Is the line undefined? No. Is the line 0? No. Is the slope of the line positive? No. Is the slope of the line negative? Yes. Yes, it is. So if you can draw it, because otherwise it's really hard to visualize it. Next, if you can use parentheses to separate values or variables, do it. A lot of the times people are doing the question correctly, but they mess up with the sign change, and they do that on purpose. They try to make things that mess you up with sign changes. So make sure you change it. Make sure you use parentheses when you have to. Here, this problem right here is a lot different than this problem right here. That gives you way different results, okay? That gives you very, very different results. So in this here, you have to distribute the negative to both of them, and then you end up with a -7. Here you only have a -6 and you have a +7. That gives you very different results. So if you have to use a parentheses, then you use it. If you can, use a parentheses so you don't miss any signs that you might need to distribute. You don't forget that you might be adding, or you might be multiplying, or you might be dividing. Don't be afraid to use parentheses as much as you can. And that would be the last slide. So I hope those strategies were helpful. We're going to go on next You should watch the next video, which should be hopefully math formulas and concepts that you need to know for the SAT. So hopefully those will help you, and I'll see you